Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P16C4 indicates an issue with the engine mount actuator. This specific trouble code points to the power circuit being stuck off, thereby affecting the vehicle's ability to effectively manage engine vibrations. The engine mount actuator plays a crucial role by controlling the position of the engine mount, ensuring smoother driving experiences by reducing vibrations felt in the cabin. Located within the engine compartment, specifically tied to the active control engine mount, ACM, the actuator relies on a power circuit to function correctly. Inconsistent power supply can lead to excessive vibrations, which compromise both comfort and performance. Troubleshooting this error necessitates a systematic approach to identify whether the fault lies in the control unit, electrical connections, or the circuit itself. The engine mount actuator's primary function is to manage the engine's position to reduce vibrations that reach the cabin. The active control engine mount, ACM, works by dynamically adjusting the stiffness of the motor mount based on the engine load and RPM settings, creating a more pleasant driving experience. Components like the ACM control relay significantly influence the actuator's performance by regulating the voltage and signals sent to the mount. Specifically, the relay is housed within the driver's under-dash fuse relay box, making it a key component in the power circuit that operates the actuator. The engine mount control unit, typically found in close proximity to the engine itself, interfaces directly with the ACM and is essential for proper functioning. Understanding their roles and locations is paramount during troubleshooting steps. Intermittent electrical failure is one potential cause of DTC P16C4, indicating that the system functions correctly at times, making diagnosis more complicated. This scenario might arise from poor electrical connections at the engine mount control unit or the driver's under-dash fuse relay box. Loose terminals or corrosion can significantly affect the reliability of the power circuit, leading to component failures. Another common issue involves a blown fuse located in the driver's under-dash fuse box. This fuse is crucial for the operation of the active control engine mount, and when faulty, can prevent the entire circuit from functioning correctly. Identifying these possibilities helps streamline the troubleshooting process and corner the root of the malfunction. The vehicle may exhibit several symptoms that could hint at DTC P16C4. A common symptom is an increase in engine vibrations felt within the cabin, which occurs if the engine mount actuator fails to function correctly. As the active control engine mount struggles to adequately dampen engine movement, drivers will notice more pronounced vibrations, particularly during acceleration or when the vehicle idles. Furthermore, the dashboard warning light may illuminate, indicating the presence of a fault code. There might also be unusual sounds coming from the engine compartment, resulting from the engine not being securely mounted. Being aware of these symptoms equips drivers and technicians with the information necessary to approach diagnostics effectively. The first step in troubleshooting DTC P16C4 involves ensuring that the ignition switch is turned to the on position. This action activates various vehicle systems, allowing for proper diagnostics to begin. Following this, the Automotive Diagnostic System HDS should be used to check the active control engine mount ACM unit supply voltage in the data list. Verifying battery voltage at this stage is crucial because it confirms that power is reaching the required components. If battery voltage is present, it indicates an intermittent failure, suggesting that the system is operational at this moment, but could have underlying issues such as poor connections or loose terminals. Addressing these would require examining the connections at the engine mount control unit and the driver's under-dash fuse relay box. If no voltage is present, further diagnostics will be needed. After completing the first step, it's essential to turn the ignition switch to the lock 0 position to ensure safety while performing subsequent checks. The next step is to inspect the number 14 ACM fuse, specifically a 10 amp fuse located in the driver's under-dash fuse/relay box. This fuse is critical for the functionality of the active control engine mount system, and a blown fuse could directly contribute to the DTC P16C4 error. Checking the status of the fuse involves visually inspecting it to see if the filament is intact, or using a multimeter to measure continuity. If the fuse is okay, the focus then shifts to other components in the circuit. Whereas if it is blown, immediate replacement must occur to rectify the power circuit issue. To gain access to essential components, the driver's dashboard lower cover must be carefully removed. This step is crucial for facilitating further inspection of the fuse, relay box, and the connections leading to the engine mount control unit. Once the cover is off, the next logical step is to disconnect both the driver's under-dash fuse relay box connector G and the engine mount control unit's 16P connector. Disconnections should be performed cautiously to avoid any damage to the connectors or terminals. This allows for a clearer view of the wiring and connections that may be causing issues. With these connectors detached, diagnostics can delve deeper into the continuity and integrity of the wiring that connects these components. Following the disconnections, it becomes necessary to check for continuity between terminal number 10 of the engine mount control unit's 16P connector and body ground. Testing continuity ensures that there are no breaks or shorts that could hinder the effective operation of the engine mount actuator. Utilizing a multimeter, one can measure the resistance and ensure it's within acceptable ranges. If continuity exists, it indicates that the wiring is intact, suggesting a potential short to ground issue elsewhere in the circuit. Conversely, lack of continuity points to a more direct fault in the wiring, which must be rectified. This step is fundamental in pinpointing whether the issue resides within the circuit path leading to the actuator. If continuity is confirmed between terminal number 10 and ground, the troubleshooting must focus on repairing any shorts that may be present in the wire connecting the engine mount control unit to the driver's under-dash fuse relay box. This entails inspecting the wire for signs of damage, fraying, or corrosion, which could all result in reduced functionality of the actuator. After repairing any identified issues, it is imperative to also replace the number 14 ACM fuse, ensuring that the system is restored to its original function. Once these repairs are complete, the technician should then proceed to confirm that the DTC has been cleared through further testing and diagnostics. This step emphasizes the importance of thoroughly addressing issues to prevent system malfunction in the future. Final verification of repairs is essential to ensure the integrity of the vehicle's engine management system. After making necessary repairs, it is crucial to confirm that the system operates as expected before considering the fault resolved. This involves rechecking the functionality of the active control engine mount and ensuring the engine mount actuator works without issues. Any diagnostic trouble codes, including DTC P16C4, should be cleared from the onboard diagnostic system using the HDS. Following this, a road test would also be beneficial to observe any returning symptoms and ensure that the installation of the new fuse and repairs hold up during operation. Successful completion of these steps indicates that the issue has been thoroughly addressed and rectified, promoting optimal vehicle performance. Implementing a preventive maintenance routine can help avoid future occurrences of DTC P16C4 and related issues. Regular inspections of the number 14 ACM fuse and other critical fuses in the driver's under-dash fuse box can identify wear or damage before they escalate into more significant problems. Keeping an eye on electrical connections is also vital. Examining conditions where corrosion or looseness might occur can contribute to maintaining circuit integrity. This attention to the electrical system is essential for the active control engine mount to function effectively and guarantees a smoother ride. Beyond fuses and connections, following the manufacturer's scheduled maintenance intervals further supports overall vehicle reliability, making each driving experience more enjoyable and less prone to mechanical failures. In summary, DTC P16C4 highlights a significant concern that pertains to the engine mount actuator's power circuit being stuck off. Understanding the roles of each component involved, including the engine mount actuator and its connections, contributes greatly to effective troubleshooting. By following a systematic approach to diagnostics and attending to any electrical issues promptly, we can ensure that the vehicle's engine management systems work seamlessly. Moreover, implementing preventive maintenance strategies aids in prolonging the life cycle of crucial components and maintains performance integrity. Vehicle owners should also embrace the importance of regular diagnostics to catch these issues early on. Ultimately, thorough troubleshooting, coupled with preventive techniques, not only resolves immediate concerns, but contributes to optimal vehicle functionality in the long run. Please like and subscribe to the channel. See you next time!